Now that we've talked about some of these gas inlets, let's draw the most simple path for gas to go from a patient. So we would start from our oxygen tank, and we're going to have a pressure gauge on here that will tell us that this is up to 1900 psi, which is an insanely high pressure, which is extremely dangerous. So we're going to need some type of pressure limiter here. This will make the pressure now 45 psi, which is still much too high for the patient, but at least that's more reasonable than the 1900 psi. And there's another good reason for this, which is our wall oxygen is going to be delivered at 50 psi. And these come together. We want our wall O2 to be the preferential source of oxygen going forward. So as long as this wall O2 is higher than the pressure coming off the tank, any gas flow through this circuit will be coming from the wall O2. We've already shown how quickly an O2 tank will run out. So on the order of sort of an hour for a full tank at high flows. And in our anesthetic machine, we really only want this O2 tank to be a backup supply. Therefore, this pressure coming off the tank has to be limited to less than the pressure from the wall source in order for the wall source to be the preferential supply of oxygen, or any gas for that matter. So assuming this wall oxygen works, we'll actually have oxygen coming from the wall source. And let's draw the O2 flush valve here. From this, we'll have our gas going into our common gas outlet. Which will be taken to our circle system and off to the patient. Let's just make this look a little bit different because the O2 flush valve is different than these pressure regulating valves, which will just be plain boxes. Now this is our essentially simplest path for the oxygen to take to the patient, and it's not very elegant because we're just blasting them with 50 psi when our O2 flush valve is open. Which brings us to our next point of controlling flows and decreasing pressure to safe levels. So let's draw another path that our oxygen can take here. We'll run through another pressure regulator, which just drops the pressure slightly before entering the real important component for this, which is our flow meter. Flow meter. Here you will dial in your flows on the order of liters per minute, and you'll have some type of indicator in here, either a ball or a bobbin, to show you what the flows are. If this is a ball, then you would look at the center of the ball to tell you. So maybe that would be, say, like 5 liters per minute, for example. Or if this was a bobbin indicator with a flat top, you would just look at the top of the bobbin for what your flow is at. With a lot of these machines, you'll be physically dialing in this flow with a knob, and others will have digital flow meters. In either case, before you do an induction, make sure you look at what this oxygen flow is, because sometimes the default is either off or something low, and for induction, you want your flows to be high, like 15 liters per minute of 100% oxygen. So before you pre-oxygenate the patient, just remember to look at your flows and make sure that you are indeed pre-oxygenating them and not giving air, for example. After this flow meter, the gas will run through a vaporizer, picking up volatile anesthetic, and then running down to our common gas outlet. As you can see, this is a much more elegant route because we're controlling our flow of gas, and it's also picking up a volatile anesthetic, and that's being delivered to the patient rather than just blasting the patient with oxygen through our O2 flush valve. There's going to be other gases that are mixed together by this anesthesia machine. So we'll draw our nitrous here coming from a nitrous tank. Here's our pressure indicator saying that this tank has 745 psi, which makes sense no matter how full it is. And then we will have a pressure regulator because 745 psi is insanely high. Preferentially, we want to use our nitrous from the wall or the pipeline supply. And if you measure this, it will be 50 psi, which is above the 45 psi, which the cylinder is limited to. Therefore, nitrous will be preferentially drawn from the wall instead of our cylinder. Then there will also be a nitrous flow meter with some indicator ball here. Then your gases are mixed and sent to the vaporizer. Then what you'll have coming out of the vaporizer is your mix of volatile anesthetic, oxygen, and nitrous, which will be delivered to the common gas outlet. There's also this O2 fail-safe mechanism that prevents other gases from flowing through when you lose the pressure in your oxygen system. So without this 50 psi of oxygen, or 45 psi of oxygen, pressing up on this valve, you will not be able to have nitrous coming through. So this will block off nitrous from entering the circuit when your O2 supply fails. So I'll draw that as an X. Your machine will also have an air supply. So I don't want to draw that because it'll just get busy and complicated here. But just know that there is going to be another gas that's entering through the system and entering your flow meters through the vaporizer and to the patient. Looking at this whole diagram now, you can see we can divide this into high and low pressure circuits. So everything coming off of these canisters before the pressure regulator is extremely high pressure. It's going to be our high pressure side. And then distal to these flow meters is where you'll have your low pressure. It's low pressure. And then anything in between here, we're dealing with pressures of 45 to 50 psi, and that's intermediate. So essentially what's safe for the patient is just anything after these flow meters.